When humans are confronted by large numbers of seemingly disorganized items, they will frequently do two things. That is, if they don't turn and run the other way. First, they'll separate the stuff into groups based on similar appearance. Next, if those groups haven't been named already, they'll name them. Basically, then, in much the same way that an anonymous launderer from the past used color, or the lack of it, to divide a large pile of dirty clothes into two smaller piles, lights and darks, the 18th century Swedish physician Carl Linnaeus, 1707 to 1778, divvied up a dizzying menagerie of animals into vertebrates and invertebrates. Here, though, the sorting depended on whether or not the critters were sporting a vertebral column, commonly referred to as a backbone. For his trouble, Linnaeus was christened the father of taxonomy, the science of separating and categorizing living things. The identity of the champion of darker darks and lighter lights remains lost to history. Now that we've got that down, let's say you were asked to list the unique features found in the vertebrates, a group or taxon composed of fish, amphibians, reptiles, birds, and mammals. The vertebral column that gave them their name would be a strong first choice. Also aptly known as the spinal column, it surrounds and protects the delicate spinal cord, while providing a sturdy attachment site for muscles, ribs, limbs, and the head. Because the vertebral column is not a solid rod but is instead formed by a varying number of chain-link vertebrae, it is also flexible enough to play a key role in movement and locomotion. Another strong candidate for our list of uniquely vertebrate features would be bone, a form of connective tissue made up of varying amounts of stony minerals, mostly calcium-rich hydroxyapatite, bendy rods of the ubiquitous protein collagen, and water. Bone tissue forms an array of skeletal structures, conveniently, though at times confusingly, known simply as bones. A caveat here is that while most vertebrates have bony skeletons, sharks and their flattened relatives, the skates and rays, have done quite nicely for the past 450 million years or so with skeletons, including vertebral columns, composed of cartilage, which is essentially bone without the stony mineral salts. And though sharks apparently never had bone, there are also a few vertebrates, like the hagfish and lampreys, that lost theirs somewhere along their respective evolutionary paths to corpse munching and parasitism. For these reasons, bone occupies a spot slightly below the vertebral column on my personal list of distinctly vertebrate traits. What about brains, you might ask, utilizing some of the 86 billion neurons that make up the human model? But after checking with official scorers back at the studios in New York, that particular feature gets the thumbs down. The reason is that unlike the vertebral column and bone, possession of a brain isn't limited to vertebrates. These complex organic computers evolved much earlier in invertebrate groups like insects, crustaceans, and spiders. Eventually, brains were passed on from ancient invertebrates to the ancestors of the first creatures with a vertebral column. Finally, although possession of a large brain is often considered a vertebrate trait, it should be noted that the brains of both cats, vertebrates, and octopuses, invertebrates, contain roughly 200 million neurons. Dogs' brains contain around twice as many neurons. Like the vertebral column and bone, there is yet another vertebrate innovation that sits near the top of our list: teeth. Teeth are that important, I will argue, because much of the diversity and long-term evolutionary success of the vertebrates can be attributed to their presence. The appearance of teeth around 500 million years ago, and the serious remodeling that occurred after that, enabled myriad forms of vertebrates to obtain and process food in pretty much every conceivable environment, from sun-torched deserts to oceans and rainforests teeming with thousands of species of animals and plants. This matching of organism and environment forms what is otherwise known as an ecological niche, and the ability of organisms, including plants, to successfully fit into and exploit a particular niche depends on their having evolved a suite of characteristics called adaptations.